April 2026, a Dutch research vessel was stranded in the South Atlantic. 3 dead, 12 countries raised alarms. Passengers had already scattered across the world. No one knew who was carrying it. The virus, Hantavirus. After that, everyone asked the same questions. Where did it come from? How did it spread? Are we safe? Wrong questions. The right ones. Why has this virus been here for 100 million years and we still don't fully understand it? Why do the strongest immune systems collapse the fastest? Why did just one variant, for the first time in all of hantavirus history, cross the human-to-human threshold? And in human hands, how much more dangerous can this become? Do you want to know the answers? Like the video and support us. Let's begin. This is Silent Tab. Today you clean something. Maybe an old storage room, a garage, a corner untouched for years. You saw no mice. You smelled nothing. No warning signs. Nothing that told you to stop. But there, suspended in an invisible aerosol, rodent urine, dried and reduced to microscopic dust, viral particles were hanging in the air. One breath, that's all it takes. Hantavirus is a negative-sense single-stranded RNA virus. 3 genomic segments. The small segment encodes the nucleocapsid protein, the protective shell around the virus's genetic material. The medium segment encodes the glycoprotein envelope, a surface structure that binds directly to beta-3 integrin receptors on the outer wall of your endothelial cells. The large segment carries the RNA-dependent RNA polymerase, the replication engine. Structurally, it looks simple. It cannot copy itself without a living host cell, your cell. The entry point is the deepest architecture of the lung, terminal bronchioles and alveoli. The virus infects alveolar macrophages first. Then it infiltrates capillary endothelial cells, the thin inner lining of your smallest blood vessels. Replication begins. Silent, invisible. Day 1, day 5, Day 10, you are going to work, picking up your child from school, sitting across from someone at dinner. Incubation period, 2 to 8 weeks. The median is 18 days. For 18 days, you are a carrier. You don't know. No one around you knows. Then, one morning, something shifts. Fever. Muscle aches, a heaviness behind the eyes. Coming down with something, you think. You see a doctor. The doctor thinks the same. At this stage, hantavirus-specific testing produces no reliable results. The symptoms are clinically indistinguishable from influenza. You go home with instructions to rest and drink fluids. That decision, for many, is the last one made with complete information. 4 to 10 days later, you're coughing. Breathing becomes labored. There's a tightness in the chest that won't release. Your lungs have begun to fill with fluid, not because of external damage, but because of what is happening inside your own capillaries. The cardiopulmonary phase has started. From the onset of this phase, the vast majority of untreated patients die within 24 to 48 hours. Ventilator, ECMO, supportive care. Nothing stops the virus itself. You can only wait to find out whether your immune system wins or loses. No specific antiviral drug exists. No approved vaccine exists in the Western world. Discovered 33 years ago. Still nothing. Step back for a moment. Paramyscus maniculatus. A small, brown, entirely unremarkable rodent found across nearly every environment in North America. Forests, meadows, desert margins, attics, garages, warehouses, the walls between your walls. Estimated total population, over 200 million. A significant portion of these mice carry sin nombre virus. None of them get sick. This isn't resistance in any conventional sense. It goes far deeper. Research shows that deer mouse endothelial cells produce no antiviral gene expression when exposed to sin nombre. The virus replicates within these cells with such efficiency that the cell's pattern recognition receptors cannot detect the critical viral structures. No molecular alarm is triggered. No immune response is initiated. The mouse doesn't know the virus is there, doesn't feel it, doesn't fight it, carries it for the entirety of its natural lifespan, in urine, in feces, in saliva, in every particle it leaves behind. This blindness is not accidental. It is the engineered result of hundreds of millions of years of shared evolution. Hantaviruses are thought to have co-evolved with their mammalian hosts from at least 100 million years ago, before the extinction of the non-avian dinosaurs, before the first primates, before anything resembling a human ancestor walked the earth. Some phylogenetic analyses suggest this viral family may have emerged first in bats or insectivores before jumping to rodent species. The lineage is ancient in a way that resists easy comprehension. This virus made a contract with its carrier before our species existed. The terms, "I will not kill you. You will carry me for life, without knowing, without stopping." 200 million living repositories, each one a sealed copy of that agreement, scattered across every ecosystem on the continent. You were never part of the negotiation. The virus infects pulmonary capillaries. But the damage that follows doesn't come from the virus. It comes from you. The immune system detects a threat and mobilizes at full force. Pro-inflammatory cytokines flood the tissue. CD8+ T cells activate and proliferate. Vascular permeability increases. The walls of your capillaries begin to leak. Fluid moves from the bloodstream into lung tissue. The lungs begin to fill. This is the mechanism that normally terminates an infection. In hantavirus, it loses all calibration. The cytokine storm doesn't stop at the appropriate threshold. It escalates, and the target becomes your own lung architecture. Your defense forces are not fighting the enemy. They are dismantling the building they were designed to protect. And here is the part that no standard coverage mentions. The intensity of this response scales directly with the strength of your immune system. The stronger you are, the harder the storm. 1993, 4 corners, 33 cases, 17 dead, a 56% case fatality rate. The victims were predominantly in their 20s and 30s, young, healthy, athletic, peak physical condition, strong immune systems, exactly the profile you would assume would survive. They didn't. The Korean War, 1951 to 1954. More than 3,200 United Nations soldiers fell ill with an unknown hemorrhagic syndrome along the Hantan River. Young men, peak fitness, fever, internal bleeding, renal failure. Fatality rates between 10 and 20%. A name was given, Korean hemorrhagic fever, and the file stayed open. The cause of those deaths was not identified until 1978, 25 years after the war ended, when virologist Ho Wang Lee isolated the responsible agent from field mice along the same river. 25 years, unanswered. In rodents, the mechanism runs in reverse. Pro-inflammatory responses are actively suppressed. The immune system stays quiet. The virus settles in without friction, without consequence, without end. Being physically stronger does not protect you from this virus. In the cardiopulmonary phase, it makes you a more efficient target. For decades, a single rule governed all known hantaviruses: animal to human, never human to human. That boundary acted as a natural ceiling on every outbreak. Each case required an animal source. The transmission chain broke at the human level. The spread remained geographically and numerically contained. Then Andes virus demonstrated it didn't recognize that rule. Argentina, Chile, human-to-human transmission, documented, confirmed, reproducible. 1996, El Bolson, 16 cases, 9 deaths. 5 of those patients had no recorded rodent exposure of any kind. Their only contact was with an infected person. In 2014, full genome sequencing confirmed what the epidemiology had already established. The mechanism was real, not statistical noise. And in 2026, Andes crossed an ocean inside a closed ventilation system, a luxury research vessel, and left 3 dead across 12 countries before the ship made port. Why only Andes? What threshold was crossed? What changed in the genome, in the protein structure, in the viral host interface that made this possible in one strain and not the others? The mechanism remains incompletely understood. Science has confirmed the phenomenon. The explanation is still being assembled. In 2025, researchers at Virginia Tech published findings from a study spanning 14,000 blood samples across 49 species. Their conclusion: hantavirus variants circulating in the Americas display significantly greater ecological flexibility than their counterparts in Europe and Asia, circulating through more species, adapting to a wider range of hosts. The researchers described this flexibility directly as a major warning sign for disease emergence. Sin nombre currently transmits only from animal to human. Andes once did too. Sin nombre carries a fatality rate exceeding 50%. Andes transmits human to human. They are members of the same viral family. The evolutionary distance between these two properties, across these two strains, is not infinite. The components already exist in nature, in separate packages. Science is not asking out loud what happens if they end up in the same one. But the question is there, sitting quietly in the literature, between the published lines. The CDC classifies hantavirus as a Category C bioterrorism agent. The formal definition of this category includes 3 criteria: high morbidity and mortality potential, accessibility for production and dissemination, and, this word matters, suitability for engineering toward mass dissemination in the future. Suitability for engineering. In the official federal document, USAMRIID, the U.S. Army Medical Research Institute of Infectious Diseases at Fort Detrick, Maryland, has maintained hantavirus research programs since the Korean War. The stated purpose: defense, diagnostics, countermeasure development. Known research did not advance to weaponization. But Fort Detrick's institutional history is not limited to what has been formally disclosed. In 2019, the CDC suspended high-containment research operations at the facility, citing inadequate systems for decontaminating liquid waste. What was being studied, and what may have been released during those operational gaps, was never made fully public. The official response was familiar. Everything is under control. It always is. The current technical barrier to weaponization is real. Culturing, isolating, and purifying hantaviruses is genuinely difficult. This is the wall that stands between the theoretical threat and a practical one. But consider what that same statement would have sounded like in 2018, applied to the rapid mRNA-based genome mapping of novel coronaviruses. The tools change, the barriers lower. Every year, the threshold moves. Now hold two facts together. Andes virus, human-to-human transmission, confirmed, documented, occurring naturally. Sin nombre, fatality rate exceeding 50%, natural, endemic, carried by 200 million rodents across North America. Two properties, one viral family, a combination that does not require laboratory engineering because both features already exist in nature in related strains. Picture a major city. This combined profile moving silently through it. An 18-day incubation. No symptoms. Carriers on subways, in offices, in hospitals. Then the window closes, simultaneously, across multiple districts. Hundreds of patients entering cardiopulmonary failure at the same time. No effective antiviral. No vaccine. Contact tracing structurally impossible because no one knew they were carrying it for 18 days. This is not a fictional scenario. Every biological component already exists. Nature would not need assistance. If it happens naturally, it is not classified as bioterrorism. 100 million years. That is the age of the contract between this virus and its carrier. You were never part of the agreement. No one consulted you. In 1993, 17 people died, and it took months just to name the cause. In 2026, 12 countries were on alert before the ship made port. The institutional response accelerates with every outbreak, but the virus adapts with every generation. Andes crossed the human-to-human threshold within this century. Sin nombre hasn't crossed it. Yet. Sit with that word for a moment. When Andes crossed that line, do you read it as evolutionary chance or as a signal that something has fundamentally shifted? Leave it in the comments. If you don't want to miss the next episode of Pathogen X, don't forget to subscribe. This was Silent Tab. Until next time, stay awake.